Hey, hello once again, finite math student. What's up? It's nice to see you. I can't really see you. That's okay. You can see me. Hopefully you're okay with that. Okay, so we are in section 3. I made the first part of this section already. We're ready for section 2, so let's jump into it. Make sure to comment and subscribe, hit the bell notification, whatever else I'm supposed to say to be a legit YouTuber. Do all of those things. I don't know. Okay, sharing my screen. Here we go. Nice. Make myself a little bit bigger here. Cool. All right, so in section 3, we were learning about conditional statements. Reminder that we are not going to do this circuits part. So everything in this section about circuits you can ignore. Conditional statements are in the form if, then, and we have names for the part after the if and the part after the then. We saw some examples of sometimes you don't necessarily see the word if or the word then, but we can interpret what the antecedent and consequence are. We learned how to complete a truth table for a conditional. We learned that a conditional is always true except in the case where P is true and Q is false. That's the only time that that conditional is false. All right, so we did some practice with just evaluating whether statements involving conditionals were true or false. And then we did some larger truth tables here, and they don't always work out this way, but this one worked out to be all false. So we said that that's called a contradiction, and anything whose truth table ends up being all true in the last column is called a tautology, and we're ready for these next two things to learn here. So the first one is, how can we interpret a conditional statement as a disjunction? Now in class, we certainly took time to think through this and kind of see logically why this makes sense. And I encourage you to do that at home as well. But the purpose of these videos are kind of just to keep you caught up. So I'm going to kind of bare bones it here a little bit. So it turns out that a conditional statement is equivalent to, remember what equivalent means. It means if you make a truth table for each of them, the last column in that truth table is always the same. Whenever one statement's true, the other statement is true. Whenever one statement's false, the other statement's false. That's what we mean by equivalent, logically equivalent. So a conditional statement is equivalent to this disjunction statement. Remember that symbol is a disjunction, it means or. So if P then Q means the same as not P or Q. In other words, if I say if P occurs, then Q will occur, I'm really making an equivalent statement by saying, okay, either P doesn't occur or Q does. And again, you can take some time and kind of try to wrap your mind around that. That's hard for me to kind of, interact with you on that right now in a video, but let's just see some examples here. So if it is raining, so it is raining is sort of our antecedent, we'll call that P, then I will take an umbrella. So I take an umbrella is our consequence, so that's P. So this is an if-then form. So right now it's written as P implies Q, or if P, then Q. And what we've learned here is that this will be equivalent to not P or Q. And so the way that we would say that statement is either it is not raining, and so that's not how you spell raining. So I have to negate my P statement, right? Because it says not P. Either it is not raining, or there's that disjunction, or I take an umbrella. So I will kind of walk you through this real quickly. Hopefully this makes some sense. This original statement is saying if this condition is met, then this conclusion can be made. So in the event that there is rain, we can conclude I'm going to take an umbrella. Now, if that statement is fact, that if it's raining, I will take an umbrella. If that statement is fact, then one of two situations are occurring. Either it's not raining or I have an umbrella in my hand. Now, if I have an umbrella in my hand, that means it must be, if it rained, that means I would have an umbrella, right? The other thing, if it doesn't rain, that would mean it's not raining. So it's either raining or it's not, right? I mean, at any given time, the truth is it's either raining or it's not. So here I have, it's not raining. Well, in the other case, if it is raining, well, then I'm going to have an umbrella. So this conditional statement is equivalent to this junction. I would read a book if I had more time. Be really careful about your if then here, because this is a conditional, would be if I had more time, then I would read a book. Would read a book. Sorry, I'm trying to write quickly here. So the P statement is I had more time. The Q statement is I would read a book, right? Antecedent, consequent. Now, again, if we want to write this as an or statement, we just have to do not P or Q. And so we would say, we would negate P and say either. With these disjunctions, with these or statements, I think it makes sense to include the word either. Either I don't have more time. Okay, and this says we need to make this a conjunction, or I would read a book. Okay, so, you know, at all times, I am in a situation where either I have more time or I don't. So, you know, sometimes I don't have more time. The rest of the time, I do have more time, but in those situations, I'm going to read a book. So one of these two things is going to be going on all the time. Okay, finally, we're going to learn how to find the negation of a conditional statement. Now, I want to remind you of something that we learned in, I believe, a couple lessons ago involving De Morgan's laws. So first of all, I'm going to use this idea that we just learned, that this conditional is equivalent to this disjunction. Now what I'd like to do is to negate this conditional. So I want to negate this whole conditional. I'm going to find a statement that is not equivalent to the conditional, but is the negation of that conditional. So in other words, I'm going to also negate this whole thing. Now, De Morgan's laws told us that when you negate a conjunction or a disjunction, that's actually pretty easy. You're just going to change the or to an and then negate each part. So this not P gets negated and now it's P, and then the Q gets negated and it's not Q. So the negation of a conditional statement is the same as P and not Q. Okay. Now, the original conditional statement, if P then Q, is equivalent to not P or Q. So these are some things to keep straight. This is what we just learned a minute ago. What I'm telling you now is that the negation of that conditional, a statement that means the exact or has the exact opposite truth value of the conditional, can be written as P and not Q. So you got to keep straight which of these is which. Okay, as far as doing it, once you keep it straight, it's easy. If you build it, he will come. You build it is P, he will come is Q. And so to negate that statement, we need to do P and not Q, which would be you build it. Okay, now we're using and then not Q would be he didn't come. This one's a little bit more obvious. If I say, hey, if you build it, by the way, this refers to a movie called Field of Dreams. If you haven't seen it before, it's Kevin Costner, great movie. It's talking about a baseball field. If you build this baseball field, then, and he refers to his dead father, who is a baseball player. It doesn't make any sense me saying it right now. You have to go watch the movie. And then I know it sounds dumb, but it's a great movie. So if you build this baseball field, then he thinks that his father, who's been dead for a long time, is going to come back, walk out of the cornfields onto the baseball field and play catch with them. That's what it's talking about. So if it's true that if you build it, he will come. Well, the opposite of that would be I built it. He didn't come, right? That would be the negation of that statement. It must be alive if it is breathing. I would tend to agree with that for the most part. I think I'm not a doctor, but notice that there's no if then here. So really what this means is if it is breathing, then it must be alive. I should have just said it is alive, would have been easier, but it is breathing is our P. It must be alive is our Q. We want the negation of this statement. So I'm going to do P and not Q, which would mean it is breathing. And not Q, it's alive would be it's not alive. And it is dead. Okay. So if I said, if it is breathing, then it must be alive. The opposite meaning of that would be it's breathing and it is dead, right? So that's the negation of that conditional statement. Okay, we're going to skip all of this stuff about circuits. And next time we will begin section 6.4. Look forward to seeing you there. Go watch Field of Dreams. It's a great movie. Your parents will watch it with you if you want to do that with them. That's up to you. Bye-bye.